Using the factors we went over in the last video, we can look at reactions, determine their reagents by figuring out whether an SN2 mechanism happened or an SN1 mechanism happened. So let's start with this problem. We can go ahead and start listing some of these factors, and one thing we can consider is, nucleophile. So we ended up replacing this iodine over here with this methanol group, or this methoxy group. So we know that a nucleophile could either be methanol or methoxide. So at least we have two choices. Now let's continue to go on to figure out what else could lead us on to figure out between SN2 and SN1. As for leaving group, the iodine, and in this case it's a good leaving group. It would work for either one. So we still are a little unable to make a clear decision because, like we just said before, we can use a weak nucleophile to facilitate a SN1 mechanism or a strong nucleophile to facilitate an SN2 mechanism. So what about substrate? If we look here, we started at a primary carbon and we're still with a substituent at the primary carbon. So we have a primary substrate, which should lead us to think, okay, that's actually going to be, we expect, SN2. But there's yet another thing we can consider when deciding between SN1 and SN2 in this case. Because imagine, if this iodine left as a leaving group, then we'd get this carbocation. And we should notice that this is able to rearrange. And if it were to rearrange, we would get this carbocation, which would get us a completely different product than what we got. What this tells us is that rearrangement didn't happen. And to deduce from that, an SN1 mechanism didn't happen. So we do end up with an SN2 mechanism. So now we can go back and decide what we'll use to facilitate that even further. We'd want our stronger nucleophile. And one thing we didn't talk about is solvent. Which solvent could we use? We could use an aprotic one, which would allow the nucleophile to be unhindered by any solvation shells, and thus we would get easily the product that we want. So here's how you can apply the factors to see, okay, how did a reaction go? On the flip side, we can analyze the factors we're given to determine which mechanism is used for a substitution. So let's start. We notice that our nucleophile is likely to be this iodine, and it's polarizable, and it'll have a negative charge, so it should fit the bill pretty well, either way. And another thing to notice here that might be useful is we have an aprotic solvent. So we're not going to be creating solvation shells, and that would help SN2. So now we're starting to get some ideas. But one thing that's a little difficult here is where's our substrate and what's our leaving group? Now, it can be a little hard to decide how to start, but perhaps if we find the leaving group, we know we can find the substrate. Well, what would be able to leave? And when you look at this, you'd start thinking of, okay, functional groups, I'll probably be seeing heteroatoms. Well, if we look here, this will actually be our leaving group. Because consider this. If this whole group were to leave, then I would get this. And even if you don't consider it the double bonded oxygen, you can still look and see, okay, I have a negative charge on an oxygen. We've seen that act as, or attempt to act as, a leaving group before, like hydroxide. But what's the difference here? We have resonance. So we've applied some concepts of stability here to find that, okay, we actually have a decent leaving group. So if this is our leaving group, then our substrate is this methyl substrate, which would be even better than primary, and since it has very little steric hindrance, that'd be perfect for SN2. And if we draw out the mechanism here, let me draw out our compound again. And keep in mind, even if I draw the group here to the left, it still rotates around a single bond. And let me fix this. So what's going to happen is I'll have my negative of my halogen, negative charge. That means a lone pair would be coming in attack here, which would force electrons up onto this oxygen. That would be our leaving group leaving, which once again is this whole product, leaving group, molecule you might say, and that will get us the methyl halide along with our leaving group that we've drawn before, this resonance stabilized molecule right here. While this question seemed a little more difficult, you still apply the same processes of looking at your nucleophile, the solvent perhaps to give you an idea, locating your leaving group, which you can usually do by looking for functional groups or heteroatoms, which allowed us to find our substrate. All of these are important to keep in mind because we're still going to use them in the next section when we get to alkenes and elimination.